Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Students, let us move to next question, that is question number 42, NEET Physics paper 2014. Hello students, let us solve the next question number 42. This is based on nuclear physics, that is binding energy. The binding energy per nucleon of lithium 37 and helium 24 nuclei are this 5.60 and 7.06 mega electron volt respectively. In the nuclear reactions of this one, the value of energy Q released, how much energy is released, that you have to find. The energy released is obviously that way to find by the energy released Q is binding energy of this helium, binding energy of helium, and that is 2 times the binding energy of helium. 2 helium nucleus is there, minus binding energy of lithium plus binding energy of hydrogen. The reaction is Li. The reaction I can write, you can see here, the reaction is basically Li37 plus H11 gives you helium 24 2 times, and heat released, this can be obtained, energy released is 2 times binding energy of helium. The binding energy of helium is given as 7.06, so 2 times 7.06 per nucleon. This is into, because into 4, because helium has mass number 4. Okay, so this is the binding energy per nucleon. So per nucleon the binding energy is this. There are 4 nucleons, 4, so I have to multiply 4, and how many such nuclei? 2, so multiply by 2, minus binding energy of lithium is 5.60, so 1 nuclei is there, so 1 into 5.60 into how many such nuclei is there? For lithium it is 7, so I have to multiply by 7, plus or bracket plus hydrogen is not given, so I will consider 0. If I solve this, this is 8 into 7.06 minus 5.6 into 7. This comes out to be 56, and this is 8, 7, 8, 6 are 48. 48 is 0.48, so it is 56.48 minus this is 7, 6 42, 2 carry 4, 7, 5 35, 35, 4, 35, 4 is 39, 39, 39.2. Now if I subtract that, then how much I will get? 56.48 minus, if I consider this as 39, then 56 minus 39, or if I consider this as 40, it is 16. but it is one more I will add because one less is there. So it is 17. So 17, and from here 0.48, 0.2 will go, 0.28 will remain. So it is 17.28 mega electron volt. If I see the options, so this can be written as approximately 17.3. Round off this number, this increases by 1, 17.3 mega electron volt. If I see the option and the last option is the correct one, the last option is the correct one, that is 17.3 mega electron volt. Okay, thank you.